Okay, we are going to have a look at the programming exam solution tutorial for the CheckValidMove programming extension. And we are looking at the AQA Monster paper 1 assignment, and we're going to check the Python stroke OOP version of the code and look at how we do the validate move. Okay, let's first of all have a look at, let's just double check. CheckValidMove, you can currently move off the board, validate the move so you can't. Okay, let's get the solution open in Visual Studio and have a look at the OOP version here. Let's just show it in a slightly more useful way. Okay, so we've got a number of classes here. Main subroutine here, displaying a menu, getting the choice from the user, and then playing a game in one of two modes here. Right, let's just have a look at it running. Right, show menu options, position me at the cell position here, and I can now move. If I go east, I go to the right, and the problem here is if I say south, it's not a problem. I go down, I go south. If I go back up north, and I go north again, I'm going to go off of the edge of this grid. If I go north, in fact, it wraps around to the bottom row. Okay, so we want to stop the user from making an invalid move, going off of the grid. And currently we've got validation, so if I hit X, got some validation here in that no move is made. The prompts are displayed again for the user. So we want to reuse the validation move code that validates this, but we want to check whether the user's moved off the grid. Okay, let's quit this and look to see where we're going to do this. Well, first of all, we have various classes here. Let's just follow the code here. So we are creating an object here, my game, instantiating this game class there. Let's have a look at the game class. So the constructor here sets up some private attributes. I mean, they are hidden from the outside world, outside of the game class or game object, but within we have these private attributes, and we have these methods here defined within the game class. So all of these private attributes, and actually these variables here, are available within all of these methods. So let's have a look. Let's have a very quick look at the play method actually. So while the player hasn't been eaten and the player hasn't found a flask, so here the player loses, here the player wins, or the player decides to break out of the game by hitting M, then make a move. So make a move here, and then do some validation on that move. If the move is valid, then continue checking if the player's landed on the same cell as the monster. So here, check if same cell against the monster and the player. All sorts of checks here and moves of the monster, etc., happen in this part. Sorry, from here, if move direction not equal to M. But this is the loop here where the direction is retrieved from the user's input, and that check is made. If I just press function key 12 and go down to check the CheckValidMove method of this game class, you can see there's some checking of the direction, that the user hasn't put an invalid direction in there. Hello. So N or S, W, E or M, they are all valid inputs, but this checks that the user hasn't put in an invalid input here. Okay, so we need to put some validation here. We get the self parameter passed in, just like all of the others. So this is the way Python implements object-oriented, the object-oriented paradigm. At runtime, the object, so this game object, is passed in as the first parameter, and so well, we'll see we can access all of the private attributes that make up that are part of the object here by using that self parameter that's automatically passed in, and it's invisible when passed in. So you'll see CheckValidMove, the direction is passed in, but not a reference to the object, not the self bit. So where is it? CheckValidMove here. You can see it's not passed in as a parameter. Something to get used to with Python in OOP programming. When defining methods, you need to have this special self parameter telling this method that the object on which to act is being passed in. Okay, so let's have, so we need something like, we need some additional code here. If, turn my caps lock off, if, so we're receiving the direction. So if the direction equals north, for example, now we want to check if we are on the top row. So how are we going to do that? Well, we need to find the player's position, and we can access that because the player here is a local attribute, a private attribute. It's an object based on this character class. So what I can do is I could use this get the object. Okay, and now if I hit dot, gives me, because this is now object-oriented programming, this is giving me a list of attributes and methods that are available to me. You can see I've got some methods here. I can get the position of the player. I can have the player make a move. I can also access enemy awake. I can access these protected attributes by the look of it. Okay, because player, well, player is a is an object based on the character class, which itself is a subclass of the item superclass, and that has these protected attributes, which are available to the subclasses of the item. To be really fair, this bit of code actually is in the game class, isn't it? So I'm not really sure we should have access to these. I'm not going to worry about this too much. This is possibly Python not strictly hiding the protected private variables here. I'm not going to worry too much about these. But when accessing objects and manipulating, retrieving information about them, and managing them, we use methods. Okay, these are the external parts of the they're what are exposed to the outside world. So get position is the obvious method to use. That's going to retrieve me the position of the player. Now, if I put in another dot, it hasn't given me a choice, which is a bit of a shame. But if I go to get position, what does get position return me? So get position is a method of the item class. We know that player is based on a character which inherits from the item class. So this is why we can see the position here. So get position returns a cell reference. Here, return position, which is a cell reference, which itself is a class, and that returns one of these element positions given by the number of cells to the east and number of cells south. So, and we can see if we go to the game setup, wherever that is, setup game, you can see here if it's not a training game, so if it's a normal game, the positions are set to 0 at the start of the game. So if you saw that the player was positioned in the top left cell, they are given by position 0 column and 0 row there. So that's useful to know. Okay, so going back to my validation. So if the player.getPosition, and if you remember that returns a cell reference, and I'm going to go back up and so cell reference, number of, let's say get that, that's one of the, that's a that's an attribute there of the cell reference class. And we haven't got a double underscore, so we're saying it's globally available, it's publicly available. So I can get position, number of cells east, test if that is, in fact I want number of cells south, don't I, to give me the number of rows. So now if direction equals n, and so we're one ahead north and we're at the top row, then that's an invalid move. So we could put valid, is that capital? Valid move equals false. So if direction is north and we're on top row, then that's an invalid move. Let's put in the other 3 invalid moves while we're here. I'm going to put just to make it clear, a bracket there, and we'll do an OR, and you'll see what I'm doing. Put it there. Okay, so if the direction is north and we're at the top, it's going to be invalid, or if the direction is south and we are at the Now Python doesn't like this, does it? I think if I put a bracket here and then a bracket at the end, it'll know that I'm breaking over lines. Number of cells. Now, what's the bottommost row? We've seen it here. It's this NS of the game class. So I can access anything to do with the game class by having this self. So self.double_player accesses me the private attribute player, and if I need to get hold of the north-south, I can access it by accessing the self object as well. Okay, now if I try and head east and number of cells east is 0, then I'm trying to head to the left and that's going to be invalid. And if I try and head west, and I can do self dot, will that give me a choice? Yes. So north, south, and then there's west, east as well, isn't there? So all of these combinations are invalid moves. So this final one, I'm going west, but I'm positioned at the westmost column. Okay, I could do so. Okay, I've got two different validations here. I could add a bit of, I could add a useful message as well, couldn't I? So look, I'll go there, enter a valid character, and here enter a valid move. Let's get this lined up. So yes, you've moved off the grid. Please enter a valid direction. Okay, now this should be enough. So we passed in the direction as a parameter, so we use that. We didn't need to pass in the player's position because we're in a method of the game class, and the game class has all of these private attributes in play anyway. So we can access all of these from within any of these methods. So I didn't need to pass in the player's position. I can actually get them from the private attributes. Okay, let's see if this does the job. I don't know if that click started it or I just happened to click at the right time. Okay, start a new game. So I can test right at the beginning, can't I? Let's see if the messages that I've put in do the right thing. So if I put in an X, it should tell me, yes, please enter a valid character. It's offering me again some valid options. So if I try and go north, that caused a bit of a problem, didn't it? What could have been the problem there? I'm going to put in a breakpoint and start. And I'm afraid we have to sit here for another half a minute unless I can edit this part of the video. I wonder if I need open close bracket here. Maybe that's the problem. Head north. Okay, valid move. Okay, that's direction north. I mean, I can, if I just put this into, let's see if I show the local media window there, and didn't show me anything there, which surprised me. If I put in an open close bracket to say I'm running a, nope, didn't make a difference. No, it didn't like that, did it? Didn't like that, and it's gone into some sort of behind the scenes error handling in Python. I'm going to get rid of that. Let's see, how can I do this better? Not entirely sure what was wrong with that. I can get rid of this. Direction equals player position. That should be fine. Okay. I am going to create a new variable called position and set it equal to the results of this call, and I'm going to it should make absolutely zero difference, but at least I'm going to see if the position was properly set. Right. Okay. North, no good. West, no good. East, okay. Okay, I've hit a flask. Start again. Go east, east. Monster's eating you. Go east, 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 east. I've been eaten. This is great, isn't it? Right, east again. I'm confident. There we go. Moved off the grid. Going to go south, 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 south. Oh, look at that, didn't get eaten. And now I should, if I go south again, go off the grid, thereby meeting this requirement here. Direction is south, number of cells is south is 4, then validate move false and give me the error. So south again, there, moved off the grid. Okay, so this is our solution for CheckValidMove. So updating the method within this method within the game class.